Hi, I'm going to go through a Stoich quiz fast. It covers a lot of stuff. If you get stuck on a part, I'm going to tell you where to go to my YouTube page and you can watch another video that will help you with that. But I'm not going to stop and explain every little detail right now. I'm just going to fly through it. So here we go. So here's our problem. If one were to combine 90.505 grams of magnesium chloride with 50.35 grams of lithium hydroxide, then what's the balanced equation for this reaction? First thing you got to know is how do you know what magnesium chloride is? There's a video on my webpage called Elements, their names and their formulas and their charges. Go look at it if you don't know what I'm talking about right now. Let's get started. Magnesium is a plus charge if it's bonded with something. Chloride is a -1 charge, so you need to have MgCl2 to balance, neutralize it rather. Then we're going to add this to lithium hydroxide, Li. It's a +1 charge. Hydroxide has a -1 charge. These two are neutral, +1, -1. Cool. So now they're going to rearrange. Magnesium is 2+. What else can it be bonded with? It's already been with chloride. The only other thing it can be with has to be negative. It's going to be hydroxide. So there's hydroxide. Well, hydroxide is -1. So we'll need 2 of those to neutralize the magnesium. Then you're going to add that. Got some lithium left over. Haven't dealt with that. Remember, that's positive. What's it going to be bonded with? Well, it already was with hydroxide. The only thing left over is chloride. It's going to be Cl. Lithium is +1. Chloride is -1. That's neutral. All right. If you don't understand that stuff, go back and watch the video on elements, their names, and their charges, and molecular formulas. That will help you as well. Now that we have the right formulas, we have to balance. I don't like the way that looks. It's got 1 magnesium here, 1 magnesium there. 2 chlorides here, 1 there. So the only way we can fix that is by getting 2 of whatever the chloride is bonded to. So now we've got our 2 chlorides, 2 chlorides. 1 lithium, 2 lithiums. You can't put a 2 here, that changes the formula, so we put a 2 in front. 2 lithiums, 2 lithiums, 2 hydroxides, 2 hydroxides. We're balanced. We get 1 to 2 to 1 to 2 ratio. There's a 1 to 2 to 1 to 2 ratio. First part's done. What are the reactants? Well, MgCl2 and lithium hydroxide. What are the products? Magnesium hydroxide and lithium chloride. Notice I don't put the 2 there because that just tells us how much of it is there in a balanced equation. This is the identity of it. Moving forward, what type of rearrangement pattern is this? You don't know this yet, but you will soon. This is called a double displacement, and that's my dog barking in the background. It's always something. All right, now the next part is what is the limiting reagent of this reaction? There's a bunch of different ways to do it. You know that I've got one favorite way, and I'm going to do it that way. All right, I like to use the mass that we have to start with and then do some conversions. So there's 2 things I know. I know the grams of magnesium chloride that I have, and I also know the grams of lithium hydroxide that I have. I'm assuming that's what I start with. Okay, so what we want to know is which one of these products do we care about, magnesium hydroxide or lithium chloride? Let's keep reading the problem to see which one matters. Here it says hydroxide containing compound are produced. So let's look for the product that contains hydroxide. That's magnesium hydroxide. So ultimately we're going to try to find that. We're going to go from grams of magnesium chloride to grams of magnesium hydroxide. We're going to go from grams of lithium hydroxide also to grams of magnesium hydroxide. Notice they're both the same products of what we're trying to go to right now. Can't do it in one step unless you use mass-mass ratios. I'll put a video up for that. So we're going to go from grams of magnesium chloride to moles of magnesium chloride to moles of magnesium hydroxide. And I'm going to stop there, and I'll show you why in a second. Then the other half of this, we're going to go from grams of lithium hydroxide to moles of lithium hydroxide to moles of magnesium hydroxide. Notice that we're ending the same, each of these different little steps. That's important. All right, so over here I've got 1, 2, that's 2 conversions. First would be grams of magnesium chloride on bottom, moles of magnesium chloride on top. Second one is moles of magnesium chloride on bottom, moles of magnesium hydroxide on top. There's my tool. I put numbers in, and then I'll be able to use it. I know the mole-mole ratio is an easy one here. I take that from the balanced chemical reaction. And that is a 1-to-1 ratio. So 1-to-1. Now I've got to find out how many grams of magnesium chloride equal 1 mole. So put 1 mole of this stuff equals, and then I have to go to the periodic table, and I know that chloride is 35.5, so 2 of those is going to be 71, plus a magnesium, which is 24, so that's 95. Does that sound about right? If my math is wrong, you can fix that. I apologize. So that's 95 grams. If you don't understand this, check out my video called Molar Mass. It will walk you through that. Then we take what we started with, which here is 90.05 grams of magnesium chloride. So we go 90.05 grams MgCl2. I'm sorry this is so crowded. Put it over 1 to make you feel better about those fractions. Then we see what cancels out. Grams of magnesium chloride, grams of magnesium chloride. Moles of magnesium chloride, moles of magnesium chloride. We're left in moles of magnesium hydroxide, MgOH2. So then you do your math. 90.05 times 1 divided by 95, 0.948 moles of magnesium hydroxide. All right, and now I'm going to go down here and I'm going to use a little bit more space. There's room here to work. So now I'm going to do the second half. Grams of lithium hydroxide to moles of lithium hydroxide to moles of magnesium hydroxide. Two conversions. First one is grams of lithium hydroxide to moles of lithium hydroxide. Next one is moles of lithium hydroxide to moles of magnesium hydroxide. All right, now go up there, look at the mole-to-mole ratios. Magnesium hydroxide to lithium hydroxide. That is a 1-to-2 ratio. There we go. 1-to-2. Over here, how many grams is 1 mole of lithium hydroxide? That's 16, plus 1 is 17, plus lithium, which is 7, so that's 24 grams. There's our tool, multiplied by what we started with, which was, again, 2.35 grams of lithium hydroxide. So go 3.35 grams of LiOH. Check the units, grams of lithium hydroxide cancel, moles of lithium hydroxide cancel, moles of magnesium hydroxide, do all the math, and you find out that 50.35 grams times 1 divided by 24 divided by 2 equals 1.05 moles of magnesium hydroxide. So now we've got two answers we need to compare. We're either talking about 0.948 moles of magnesium hydroxide or 1.05 moles of magnesium hydroxide. What do you choose? You choose the smaller of the two, because that means that the magnesium chloride is gone. It's run out by the time you make this many moles of magnesium hydroxide. Yeah, we've got enough lithium hydroxide to make a whole mole and then a little bit more left over. But we don't have enough of this stuff, so that's our limiting reagent. So the question is percent and all that, percent yield. Well, you got to know how much actually gets made. So we need to take that 0.948 moles of magnesium hydroxide that actually get made and turn that into grams of magnesium hydroxide. So the bottom, moles of magnesium hydroxide. On top, grams of magnesium hydroxide. And then we're going to put 1 mole of this stuff equals, that's 17 times 2 is 34, plus 24 is 58 grams of magnesium hydroxide. If you don't know where that number came from, go back to molecular formulas and molar masses, watch that video. And then here's our tool, multiply it by the 0.948 moles of MgOH2 that we're using, and we find out that 0.948 times 58, we have equals 54.98 grams of magnesium hydroxide. That's what gets formed. All right, now the question is, what's the percent yield and error if 50.31 grams are actually made? So percent yield, take what actually got made, 50.31 grams, divided by what should have been made, 0.98 grams, multiply that by 100%. We find out the percent yield equals 91.51% yield. That's pretty good. Not perfect, but not bad. So what's your percent error? Well, that's 100 minus that, so it's going to be about 8% error. All right, there you go. There's a passing Stoich quiz, folks. We just got the whole thing done in what, 10 minutes? All right, you'll get better at it. I am making more videos. If any part of this confused you, if it seemed to go too fast, or there's things I did that you don't get, you need to go back to the YouTube page and watch a video specifically on that. All right, you guys, you got this. You can do it. You have to practice. You better know your polyatomics. All right, see you soon.